Hi there, this is Ms. Page. In this lesson, we're going to talk about how to find the surface area of square pyramids. And so one of the bits of prior knowledge that we will often need to remember and use is finding the area of a triangle. Since with square pyramids, it will have sides that are triangles. And if we're finding surface area, then we'll need the area of all those triangles as part of it. So this particular triangle that we are shown here is an isosceles triangle. So I want to remind you of something that is true about an isosceles triangle. So an isosceles triangle, remember, has at least two sides congruent. And looking at it where this would be our height perpendicular to the base, so this is our base B, that height, which is sometimes referred to as the altitude, will bisect the base. So that means that if the base is 6 centimeters, then each side of it would have to be 3 centimeters. That's important because in order to find the height, we're going to want here to use our Pythagorean theorem. And the Pythagorean theorem only works on a right triangle. So we need to look at basically 1/2 of the isosceles triangle. And then our 5 centimeters would be our hypotenuse, which is C. And we would use the 3 centimeters and our height h as our two legs, creating this right here. And then that gives us h squared equals 16 square centimeters, and taking the square root of that for our height, we get 4 centimeters. Then we need to, of course, if we're going to find the area of the triangle, we need to remember the area formula for a triangle, which is 1/2 times base times height, or some of you might like to use the form of it as base times height divided by 2, which of course is equivalent to that. And so our base, remember, would be our 6 centimeters. That's our bottom edge that's perpendicular to our height. That right angle is important for identifying that. We calculated our height earlier as 4 centimeters, and basically that's half of 24, which gives us then 12 square centimeters as the triangle's area. All right. So when we go to find surface area of a square pyramid, what will be true is that the square will be the base. So we have capital B as our base area, and that would be S squared, where S is a side measurement of the square that is the base. The other pieces of our triangle would be our sides, and those will all be triangles. And because our base is a square, all of those triangles are going to be congruent to each other. So all of these sides would, of course, each measure S. And then each one of those triangles would have a height here. But we have to be careful that when we are dealing with a pyramid, which is in 3 dimensions, remember, h represents the height of the pyramid, not the height of the triangular sides. The height of the triangular sides, which runs along the edge, is actually our slant height, which we use L for. So you can calculate the areas of one triangle and then multiply by 4, or if you want to calculate them more quickly, maybe in a way all at once, similar to what we did with our prisms, you can take the perimeter of the base. That's what we're looking at here. So P is the perimeter of the base, which is the square. So we'd be adding up 4 S's, or taking 4 times S. And then we take that would be then times the height of all 4 of our triangles, which would be our slant height L. And then multiplying by 1/2 as the factor of the area triangle, or dividing by 2 if you prefer. So that's looking at it in terms of a formula. So we have this formula, which becomes this more specifically, where P is 4S and base area is side squared of the square base. You can also look at it as a net. The net would be 1 square, which is our base, and 4 congruent triangles. So you could just look at it too as calculating the area of the 4 triangles. So the area of one triangle would be 1/2 times its base, which is S, times its height, which is the slant height L. That's what we're looking at here. Area of one triangle times 4, plus then the area of the square, which would be S squared. Your choice when we're doing problems. All right, so let's take a look at an example here. So here it says Grace is going to paint all surfaces of the square pyramid. So that we're looking at the total surface area, all 4 triangles and the square base. We are to find the area that will be painted to the nearest 1/10 of a square foot. So we want to make sure that all of our linear measurements are in feet, which they are. And here we have to be careful because we have to realize that the 6 feet, the arrow for the 6 feet is pointing at this line segment or measurement here, which is from the apex of the pyramid down to the middle of the base. So that we have to realize is our height H of the pyramid. And so one of the things that we're going to have to calculate is the height of each of these slanted triangles, which will be our slant height L. You have to figure out what that is. What we have to be aware of is then we have a right triangle between our H and our slant height L and this segment here, which we have to know the measurement of. Notice it's not given. So what you have to realize that for a square pyramid, that the height H, this point right here, that's going to be in the exact middle of that square. So it is going to be half the distance or half the length of a side edge of the square. So 2 feet is our side edge S, and this measurement here would be half of that 2 feet, or 1 foot in this case. So when we go to calculate L, which is our slant height or height of all of our triangles, and we'll use our Pythagorean theorem, but what we'll have then is our height of 6 feet squared plus half of S, which will be 1 foot squared, and that will equal our hypotenuse, which is our slant height, L squared. So this gives us 36 plus 1, which is 37, and that's our L squared. Taking the square root of that, principal square root, meaning positive, is going to give us our slant height L for each of those triangles. Now, you could exactly use the square root of 37 if you want to try it that way. You could round it, but make sure for accuracy's sake that you go further out than the nearest 1/10. So if you want to round it, I would say round it to say the 3rd decimal place at least. So if we're going to use a rounded measure for our slant height L, going out to 3 decimal places, we get about 6.083. The units on that measurement are going to have to match the units of the 6 and the 1, which are both in feet. So this is also linear feet. So now we should realize that we actually have everything that we need to find the surface area of this pyramid. So our surface area, remember, will be our 4 triangles plus our square base. So our 4 triangles, we have 4 triangles. Area of a triangle is 1/2 times the base edge, which is our S of 2 feet, times our height of each triangle, remember, which is our slant height L, 6.083 feet. And then we'd add to that the area of the square base, which would be that 2 feet squared. So here we're going to get feet times feet, which is square feet. Here, remember, we're squaring the 2 and the feet, so we're going to get 4 square feet there. So our square feet plus our square feet will give us a total of square feet, which is an area unit and also matches what we're supposed to find according to the instructions. So here, remember, this would technically be approximate since we're using that approximate value for L. So let's take a look at using the calculator. So I would recommend just putting all of this into the calculator first. There's really no need for any parentheses because order of operations will do the multiplication and the exponent first and then add after that, and that's what we want it to do. So rounding now to the nearest tenth, I get about 28.3 square feet. Hopefully you did too. So now I'm going to write my conclusion here. So it says Grace is going to paint all surfaces, find the area that will be painted. So the area of the pyramid that will be painted is about, to indicate that we're doing an approximation here, 28.3 square feet. All right, let's see what's next. So here we have a practice problem. I would recommend that you pause the video here, try this problem, and then come back when you're ready to check it. All right, let's take a look at the results. So this one is broken down a little differently, and if you like a step-by-step, instead of just plugging it all into the formula, you can do it that way too. But one of the most important things is right here in finding your slant height L. So hopefully you realized, like I was just instructing in the example, that this measurement would be half of the side measurement of the square. So 10 meters is our S, which means that that measurement there that I've got highlighted would be 5 meters. So our Pythagorean theorem we use on this right triangle, where our 12 meters is the height of the pyramid, not the triangular sides. And so we're looking at 5 squared plus 12 squared would equal our slant height squared. We have the square root of 169, which is exactly 13. So we have a slant height of 13 meters. So in our surface area then, what we're looking at is this is set up a little bit differently. This is using more of the formula. So this right here is your perimeter of your base, which is 4 times the 10 meters. You can alternately do it the way I did, which is 4 times the area of a triangle, which would be 1/2 times the base edge of 10 times the height of the triangles, which is our slant height of 13. So notice the 4 times 10, that's the 40. And then we have the 1/2 and the 13. So it's just organized the same information a little differently. And then plus then the area of the square base, which would be 10 squared or 100 square meters, which gives us then a total of exactly 360 square meters. And then we have our conclusion in our context. The artist will need 360 square meters of sheet metal to construct the pyramid. All right, let's move on. So another concept that we've talked about for pyramids and prisms and cylinders is lateral area. So just like for prisms and cylinders, lateral area is talking about the areas of the sides. It does not include base areas. So when we're looking at a pyramid, remember, or a square pyramid, the base is the square. So the lateral area of a square pyramid would be its 4 triangles. So we're looking at the area of all 4 triangular sides. So that would be this portion right here. And so if we only want to calculate lateral area of a square pyramid, then we would just use that first part of our formula, which is 4 times the area of one triangle, or you could look at it alternately as 1/2 times the perimeter times the slant height also. So you could do either one of those, whichever you preferred, where 4S is your perimeter calculation. All right, so let's take a look at this example here. So here it says Josh is designing a stone sculpture that is shaped like a square pyramid. He's going to polish only the triangular sides of the pyramid. So that part right there is telling us that we are dealing with a lateral area of this pyramid. We are to determine the area of stone that Josh is going to polish, which again is those triangular sides. So we are looking at realizing that we need to find the area of all 4 triangles in this case. So we have to understand that this line for the 6 inches is connecting the measurement that goes from the apex down to the middle of our pyramid base, which is our square base. So that is the height of the pyramid, which we here would call H. And then our 10 inches is slanted height, which is our L. So that's the height we need for all of our triangles. What we don't have for our triangles is our base edge measurement. We don't know what S is. So this can be a little tricky, so make sure you're paying attention here. So how do we find S? Well, we're going to have to use our Pythagorean theorem on this right triangle. You can see it. So this is our right angle in there. Didn't do a very good job of drawing that. There we go. Where the L would be our hypotenuse, the 6 inches would be one of the legs, and that little measurement right there would be, of course, the other side. We have to realize that's not S, that is half of S. So we've got a couple of steps here to find S. So the first thing we're going to do is figure out that measurement right there. So I'm going to call that A. All right, so that A squared plus the 6 squared would have to equal the 10 squared. So this is going to give us A squared plus 36 equals 100. That gives us A squared equals 64. And square rooting that gives us an A value of 8. What you have to remember is that 8 is half of your S value. So now we're going to take this times 2. And that will give us S, which will be then 16. And the units on that 16 will be the same units as our other 2 measurements, which will be inches. So now that we know S, we can now find our lateral area, L, capital L, and that would be our 4 triangles. So you can do 4 times the area of a triangle, or you could do it the other way. I kind of like this way because in my head I see 4 triangles. So area of a triangle is 1/2. The base edge of each triangle is my side length, which remember is 16 inches, times the height of each triangle, which remember is our slant height of 10 inches. So what I'm looking at here now is, so 16 times 10 would be 160. Half of 160 would be 80. 80 times 4 would be 320. Inches times inches would be square inches. So we could do that without a calculator, but it's okay if you use one, just to double check your math. And so now I can write my conclusions. Remember what this was about is the area of the stone sculpture that Josh will need to polish. So Josh will need to polish So this is an exact. We didn't do any rounding here. So he will need to polish 320 square inches. I'm going to spell it out this time. Of the stone sculpture. Whoops. All right. Let's move on. Here's a practice problem. Again, I would recommend you pause the video here, give this problem a try, come back when you're ready to check your answer. All right, let's take a look at the result. So here Joanna has a doghouse. It's shaped like a square pyramid. She wants to paint the outside of her doghouse, but not the bottom. So that means that we're again dealing with the outside surfaces of the triangles, which would be called lateral area. And so we need to, similar to the example, find the side length of each, or the base value, which is S of each triangle. And so we have a right triangle to work with here, where that measurement is half of S. And so here again, I've called it A just for something to call it, but it is half of S. And doing the math here, we get an exact value of 4 feet. And so this is done with the other formula. So if you like that, you can see this option where we do 1/2 times the perimeter P, which is 4S, times the slant height L, or setting it up for triangle areas, so 4 times area of a triangle, 1/2. The base edge measurement, remember, would be twice that A value, so 2 times 4 gives us 8. That gave us 8 feet, times our slant height, which we had to realize was the 5 feet. So that's half of 40, which is 20, and 20 times 4, which gives us 80 square feet. All right, let's move on. So here, a little closure to go over to close up our lesson here. So explain the difference between the height H and the slant height L of a pyramid. So this is a very important distinction for when we're working with surface area of pyramids of any kind. So think about that. How would you explain the difference between what we call height H of a pyramid and slant height L of a pyramid? All right, let's take a look here. So hopefully you came up with something similar to this. So the first sentence in blue, or sentences in blue, is describing height H. So the height H is the perpendicular or vertical distance from the apex to the base of the pyramid, or you could say from the base to its apex. It's found inside the pyramid right here, and is, if you recall, it's actually used to calculate the volume of a pyramid. When we learned about volume of pyramids, we needed our height H. Whereas in this case, looking at our slant height L, it's the height of each triangular side of the pyramid. So it's found here, slanted down the side of one of the triangular faces, and it is used to calculate surface area or partial surface areas like lateral area. All right, that completes this lesson. Have a great day.